Okay, so we've gone through solving systems of equations by graphing, and we graphed two lines and we looked for the place where those two lines crossed. That was our solution to the system, or maybe the two lines were parallel and we didn't have a solution, or if the two lines graphed on top of each other, we had an infinite number of solutions. And then we looked at solving systems of equations by substitution, and we were able to take one equation and substitute it into another equation and solve to determine the solution to that system. And the last method that we have is called elimination. And this is probably most people's favorite, what people term to be maybe the easier method. But to eliminate, what does it mean to eliminate something? Well, it would mean to get rid of, all right? So when I look at this system of equations, I want to eliminate one of the variables. And I can do that, okay? I can eliminate by adding the two equations together. If you'll notice, I have a coefficient here that are opposites of each other. Y has a coefficient of positive 1 up here, has a coefficient of negative 1 down here. So when I add those together, they're going to drop out. X plus 2x will be 3x equals, the y's will eliminate or drop out, and I add the constants together and I get 9. And that's something I can solve. I can divide by 3. X is going to be equal to 3. Again, we're looking for an ordered pair. We're looking for an x value and a y value, so I've got to take this up and I've got to plug it in. And it shouldn't matter which equation you plug it into. They're both going to produce the same system, the same solution. So we want to plug it in. I'll just plug it into the top one. 3 plus y equals 7. So y is equal to 4. So I write my answer as an ordered pair, just like I did with graphing and I did with substitution. Okay, let's try another system. If I have 2x plus 3y equals 1, and I have a negative 2x plus 2y equals negative 6. Okay, so I'm going to add the two equations together. And again, you notice that we have coefficients here that are opposites of each other. One's positive, one's negative. They have the same coefficient. So when I add those together, the x's this time are going to drop out, and I'm going to have 5y equals negative 5. Positive 1 plus a negative 6 is a negative 5. I'm going to divide both sides by 5, and I'm going to get y equals negative 1. So you have one of your values that you found. You're going to take that up, and you're going to plug it in to one of the two equations. It doesn't matter which one you plug it into. This time I'll plug it into the bottom equation. So I'd have negative 2x plus 2 times negative 1 equals a negative 6. Okay, and now I'm going to solve that. So I have negative 2x minus 2 equals negative 6. If I add 2 to both sides of the equation, I get negative 2x equals negative 4. Divide by negative 2, and you get x equals 2. So x is equal to 2, and y is equal to negative 1. I want to write my answer as an ordered pair. Okay. Now, those are systems or examples where you have coefficients that are opposites of each other so that when you add them together, it's going to eliminate. Now, that's not always going to be the case. You have x plus 3y equals 7, and you've got 2x plus 2y equals 6. Here's a system that I'd like to solve. If I were to add the equations together right now, the x's aren't going to eliminate and the y's aren't going to eliminate. So we have to manipulate one of the equations. If I look at the coefficients here, what's going to be easiest to set up so that I have opposite coefficients? Okay, this is a positive 2. I would need this to be a negative 2. So I'm going to take that top equation and I'm going to multiply everything by a negative 2. And you have to do everything. Whatever you do to one side of an equation, you have to do the same thing to the other side. So if I multiply up here, the new equation becomes negative 2x minus 6y equals, you have to multiply this side as well, negative 2 times 7 is negative 14. So I've taken that top equation and I've multiplied everything by a negative 2. I'm going to leave the bottom equation as it is. Okay, and now I'm ready to add the two equations together. So the x's will drop out. When I add a negative 6y to a positive 2y, I'm going to get a negative 4y equals negative 14 plus 6 is a negative 8. I would divide by a negative 4. So y is equal to positive 2. When I plug this back in, I can plug it in up here, or I can go back to the original equation. I'm going to plug that into the top equation and say x plus 3 times 2 equals 7. X plus 6 equals 7. If I subtract 6 from both sides, I get x is equal to 1. So my solution is 1, 2. Okay, and let's try one more. Okay, I've got 2x plus y equals 2. And I've got an x minus 2y equals negative 5. You've got your choice here. If I want to eliminate the x's, I would have to multiply the bottom equation by negative 2. If I want to eliminate the y's, I would just have to multiply the top equation by positive 2. I'm going to go ahead and do that. Multiply this by a positive 2, and I have to multiply both sides of the equation by that. So this is going to become 4x plus 2y equals 4. On the bottom equation, I'm going to have x minus 2y equals negative 5. If I add these two equations together, okay, you're going to get 4x plus 1x, that's 5x. The y's drop out. This would be a negative 1. If I divide by 5, I get x is equal to a negative 1/5. Okay, I just want to make sure I've got the right equation up here. Okay, this is going to be messy, but hey, we can do it. If I plug this x in, I'm going to say negative 1/5 minus 2y equals negative 5. If I add 1/5 to both sides, we get a negative 2y equals. Okay, this is a negative 5 over 1, so if I write it with a common denominator, this would become negative 25 over 5. And I'm adding 1/5, that's going to be negative 24/5. And then here we're going to divide by 2, or negative 2. So y is equal to a negative 24/5 divided by negative 2. We're going to multiply by the reciprocal here, so that's negative 24/5 times negative 1 over 2. So I'm going to get a positive 24/10, which reduces down to 12/5. So I get negative 1/5 for x, positive 12/5 for y. And again, just like with the substitution method, we can get fractions for answers, and that's just a reason why we don't stick with graphing all the time, because there's no way, very difficult to come up with that on a graph. Okay, but that is your elimination method, so go ahead and check out the worksheet for that section. Oh, and just one other thing, so we've been multiplying one equation by a specific value. There are times that you would have to multiply both equations by a value so that you have coefficients that will drop out or eliminate. Okay, so keep that in mind. You don't just have to multiply one equation all the time. There will be situations where you do have to multiply both equations in order to set something up so the one of the variables will eliminate. Okay, give that worksheet a shot.